Hi, it's Tim with Proclaim AV, and today we're in the Proclaim AV shop. Because this Sunday I experienced a mic cable failure, and I thought, well, let's talk about repairing mic cables. Let's check it out. So there's nothing more disappointing when you're setting up and you're kind of in a hurry on a Sunday morning and you have a mic cable just die, like there's no signal at all. And honestly, I thought it was the mic because the mic is rather old. But it wasn't. It was the cable, which is rather new. So we're going to take a look at how we can repair a mic cable, how mic cables are put together, and we'll do some basic soldering training. So let's get started. Okay, so let's get started on this cable here. The first thing I'm going to do is take apart the connector. Now, your connector may be different than this one. This isn't even a Neutrik, but some of the Neutrik ones unscrew. Most of them do. And some of your older Whirlwind or whatever, I think I've got one here. Will have a little set screw that you have to screw like down into, go backwards, down into the connector. Actually, it's on this side, right here. You got to screw that down into the connector for some of them. And some of them, it just comes out. So there are different ways to disassemble the connector. Here's an older Whirlwind, and that just, it's all metal, but it's the same thing, it unscrews. So it's important to figure out how to disassemble it carefully. So here, I'm just going to unscrew this. And there's our strain relief boot on the cable. So to get this out, we just should be able to pull the whole thing out. With some of these that have the, with the female end one here, you may have to press on this little button and kind of wiggle it to get it go. Because there's a spring in here you're about to see. There it is, right there. It holds that up, and it can snag when you're trying to come out of the connector. All right, let's see if there's anything wrong with this guy. Oh, and right away we can see our ground is disconnected. And that's not good. We want it to be connected. Now you can see that everything else seems to be soldered on properly. That's good. That's what we wanted. So what we need to do is clean up this solder cup here. Get some fresh solder in there and then reconnect our ground. So I'll put this into my jig, which I just showed you a minute ago. I use this for soldering because soldering really requires 3 hands. And most of us humans only have 2. So that's a problem. So let's pull this out of the way. I want to get some solder in that cup. They've used just tiny amounts of solder in production here, which I get, but I like to fill the solder cup up. All right, so let's look at a couple things I have here before we get to that. So one is I'm using rosin core solder. This is Kester branded. It's 0.08 millimeter. It's very thin. It's easier to melt and easier to work with, in my opinion. And this is lead-based solder. I do not use the lead-free. If you wish to save your life, you can do that. I'm not really worried about the lead-free or the leaded solder. I use it so little. I'm not working with it all day in production. And just wash your hands. And people say, well, there's smoke from it. Well, that's what you're seeing is the rosin going up in smoke. So anyway, that's what I've been told. Maybe I'm going to die. There we go. Leaded solder. Buy it. Use it. Love it. Also, I have a soldering iron tip cleaner, which is just like some metal round stuff shoved into this little cup. These are cheap. I buy them by a 2-pack on Amazon. And then I do have some wick, or some people call it braid. It's just pure copper in a flat braided format. And you can use it to soak up extra solder. So if your connection had like a big glob of solder that you need to clean off before you resoldered it, you can use this and it will just absorb it all. And then soldering iron. I have Milwaukee's M12 soldering iron. I like this a lot. Let me turn it on there so it starts warming up. It does have a little light on it, which is cool. And it's pretty good soldering iron. I have I don't use it if I'm doing like a ton of connections. If I'm doing a whole panel or something, or stuff in a circuit board, I'll use something different. But this works great for connectors and stuff for me. So when the green light stops flashing, oh, there it is. It's already heated up, so it's quite quick. So I'm going to tin the end of my solder iron right here. Just put a little bit on so that it melts onto the iron. And then I just push it in and out of the cleaner. And then that gets me a nice shiny tip. So, okay, so let's see. What do we want to do first? I mean, there's a tiny glob of solder in here. So let's see if we can show you how to use a braid. I don't know if that should work. So what I'll do is I'll put a little braid in here. And then just use the tip to heat everything up. And you can see that the braid has absorbed that extra solder right out of the cup. So now it's nice and clean. We can put new solder in it. So we'll do that. Let's add new solder. So this is, again, why I like using the really thin stuff. It's easy to work with. I'll do a little dot on my iron because remember, getting that solder cup warm, you can use solder to transmit the heat nicely. So you don't want to stay on this cup too long because you don't want to melt the plastic of the connector. Okay. Let's put a little more in there. Okay, that's good. Our solder cup is nice and full. Awesome. Now let's look at our connector there and see what we've got. Oh yeah. So what I'll try to do is let's tin that connector. I like to tin the braided. See, this is a braided shield. So it would have wrapped around these wires kind of, and so what happens is you just peel it all back and you twist it into a conductor, but I don't like it when it's out here in floppy. I like it nice and sturdy. So if I tin the wire a little bit, that will help. So let me clean the tip off there. So a new little drop here, and then what I'll do is I'll hold it against the wire, and then the wire should get hot enough that I can just melt solder onto the wire itself. And that's how you know I have a good connection. If you're just globbing it on with like a junky old soldering iron, big globs of solder, you're going to create a cold solder joint. And a cold solder joint is no good because it has bad conductivity. It may hold it together mechanically, but it won't work electrically. Alrighty, here we go. Now I'm going to kind of bend this so that it goes into the cup, and then that lets me pull on the wire here a little bit and kind of guide that into the cup as I melt. So now that it's all ready to go, I will just remelt the solder that's in the cup right here, and then we'll just reconnect the wire. So this is where like a third hand even would come in very handy. Then once I've got it melted and on there, hold it for a minute because it takes for a minute for it to cool enough to be hard again. Let's see if that's okay. So I think we've got it in there. Oh, good. We can tug on it. It's not coming out. So mechanically, it's a good connection. And then you can see we've got it reconnected there. It's not going anywhere. And it's shiny. So with leaded solder, you can't really tell if you have a cold solder joint or not. With lead-free solder, because it all just looks really dull. With leaded solder, if you have a shiny connection, that's a good indication that you have a good joint, that it is not a cold solder joint. If you have a dull-looking connection, that's a good indication that you have a cold solder joint, and it may not work well. And it may work initially and then fail. So, all right, good. Turn my soldering iron off here. Oh, this Milwaukee one, by the way, the red light will stay on until it cools, the tip cools down, because your tip is still hot. And I've put down something here to catch solder blobs. You can see I've got blobs of solder and stuff on here, and it won't melt through it. Okay. so it protects my table. But the tip of the soldering iron stays hot, and that will melt right through this. I'm not going to demonstrate. Because the end of your soldering iron could be, 500 to 700 degrees, depending on where you set your level. This one is preset, so I'm not sure of the exact temperature, but I think it's closer up to 650, 700 degrees. And the whole metal part of your soldering iron will get hot, very hot, so do not touch it, because you will burn your finger, and that is not fun. Ask me how I know. Okay, let's... All right, let's reassemble here. So on this one, of course, it's easy to tell which way this goes because we know where this little spring clip has to go under here. Here's a tip. Flip this upside down so that the this mechanism hangs down, and it's going to be a lot easier to put it together. All right. And as I say that, of course, it's going to be difficult to put together. There we go. And it should just slide in there. And then it should be flush with the face there. And your little springy thing should work nicely. All right, then slide your sleeve in. Remember, on the sleeve, there's a little tab here that goes into the slot. So just look on your sleeve and make sure the tab lines up. And that'll make sure that everything works properly. All right, and then we're just going to put it back together. And then grab your cable tester and verify that everything is working properly again. But we've just repaired this XLR cable, and I will put it back into service. Hey, I hope that was a helpful video. And I know some of you are going, Tim, I shouldn't be anywhere near a soldering iron. And I get it. So for you guys, just have spare cables ready to go. Don't just be running on the bare minimum number of cables. And maybe there's somebody in your church who's retired from the electronics industry or whatever who would know how to solder something, and you can chat with them and see if they can repair cables for you. Anyway, have a great day, and thanks for watching.